supposed to be cube. I don't know why in a hurry I just wrote square. So I'm just not evaluating these two questions for the time being, but we can discuss how to solve it. Okay.
Okay, ma'am.
So many of you were stuck here. So this seems easy now. So if you take like sine A common, so you have 1 minus 2 sine square A, right? And then if you take cos of A common, so you have 2 cos A minus 1. Now who will tell me how should I do it? Sorry, 2 cos square A minus 1.
Ma'am, 1 minus sine square is cos square A. So, like that.
But I have 2 here also, right? 1 minus 2 sine square A. If I
Ma'am,
use...
so 2 cos square A?
No. The identity is this, that sine square theta plus cos square theta is equal to 1, right? So I can find the value of, let's say, cos square theta is 1 minus sine square theta. So I should have only sine square theta, not 2 sine square theta here. If, as you are saying, Harsha, you are saying that I should get 2 cos square theta. So in that case, I need to multiply the whole thing by 2. So I should have 2 here. So in that case, I can get 2 cos square theta. I mean, I'm multiplying the full identity by 2, so there's no problem. Okay. But I have 1 here, right?
Yes, ma'am.
Yeah. So what will I do here? See, first of all, I replace this 1. So you can write it sine A into this 1. You can write sine square A plus cos square A and minus of 2 sine square A. And similarly in the denominator you can do, so cos A into 2 cos square A minus, now you have minus 1, so cos square A minus sine square A. I mean, both will become minus, or you put a bracket and then open the bracket, right? Okay.
Yes, ma'am.
Now sine of A, so you have sine square A minus 2 sine square A. So how many sine you have? Minus of sine square A, correct? Yes. And then in the denominator you have cos of A, and then 2 cos square A minus cos square A, that will be cos square A and minus of sine square A. So now you can see the whole bracket will actually cancel out. So sine A by cos A is tan A. Okay.
Okay, ma'am.
Yes, Hamna.
Yes, ma'am.
Okay. And yeah, Harsha, I want to say one thing you have done in question number 2. You are writing 1 minus cos theta whole square as 1 minus cos square theta, right? Is this correct?
Ma'am, question number 2.
Yeah, in question number 2, actually, like after solving it, you have a term like this, right? So can I write 1 minus cos theta whole square as 1 minus cos square theta? This is wrong, Harsha. This is a minus b whole square. Whenever you have square of the full bracket, you have to open it with the help of identity, a minus b whole square. It will be 1 square plus cos square theta minus 2 cos theta. That will be the answer. Okay.
Okay, ma'am.
Not this. So please note it. Okay, Hamna, any question you want to discuss? I think all of you have not done the last question, right? Third question also, Harsha, you have not done.
Ma'am, can you discuss that?
1 plus cos of A and then divided by 1 minus cos of A. Whenever you see a square root in the denominator, try to rationalize it first of all, because with the square root, you cannot do much, right? So you can rationalize it. that 1 plus cos of A and divided by under root 1 minus cos of A. So you multiply it 1 plus cos of A and divided by 1 plus cos of A. Clear?
Yes, ma'am.
So this will become like if I take everything inside the square root. So it is 1 plus cos A into 1 plus cos A. And here it becomes 1 minus of cos A into 1 plus cos A, right? So now
Yes.
in the numerator, you have two terms and then square root. So only 1 plus cos A will remain, right? Like 1 plus cos A whole square you have, and then square root will go away with the square. And in the denominator, I have A minus B into A plus B. So it will be A square minus B square. So 1 minus of cos square A. Clear?
Yes, ma'am.
It will be 1 plus cos of A and then under root sine square A from the identity. Now again, it will be 1 plus cos of A and divided by sine of A. And okay, because RHS is not given, so you can like split it 1 upon sine A plus cos A by sine A. So the answer is cosec A plus cot A.
Ma'am, can you explain the 11th question also?
11th, okay. 11th one is quite easy actually. Let's do it. 11th question is cosec A minus of cot of A whole square, right? And you have to show it 1 minus cos A upon 1 plus cos A. So just simplify it 1 upon sine A and minus cos A divided by sine A whole square, right? Take LCM, so you have 1 minus cos A and divided by sine of A whole square. Clear? So you have 1 minus cos of A whole square and divided by sine square A. So 1 minus cos A whole square, and this can be written as 1 minus cos square A, right?
Yes, ma'am.
Okay. So 1 minus cos A whole square. Now this is A square minus B square in the denominator, right? 1 and 1 square, same thing, okay? So I can write it 1 minus cos A into 1 plus cos A, no problem.
Yes, ma'am.
So in the numerator, like one bracket will cancel out and only 1 minus cos A and upon 1 plus cos A will remain.
Okay, ma'am.
Yes, Hamna, should I open your test paper here? I think. Can you hear me, Hamna? Rida? Okay, anyway, I'll check it and give you marks, but let us discuss the last question also. Some people have not attempted it. 12. So this is 1 plus cos of theta and plus sine of theta, and then divided by 1 plus cos of theta minus sine of theta. Okay. This you have to show to be equal to tan theta, I think. No, 1 plus sine theta 1. Now you look at it very carefully. Can you see something like if I combine these two terms, so it is a plus b upon a minus b kind of thing, right?
Yes, ma'am.
Okay, so I'll try to rationalize it. because there are no squares, and unless you have square you cannot use any identity, because identities have square terms in it, right? Cos square, sine square. So I need some extra terms. So for that I'll rationalize it. So I'll write it like this: 1 plus cos theta and plus sine theta divided by 1 plus cos theta and minus of sine theta. Now multiply it with this thing: 1 plus cos theta and plus sine theta divided by 1 plus cos theta and plus sine theta. Okay, so I'm rationalizing it. All right.
Yes, ma'am.
Yeah. Hamna, please unmute your mic. Rida, you also. So in the numerator, now I have 1 plus cos theta and plus sine theta whole square, right? And in the denominator, now I have a minus b into a plus b kind of thing in the denominator, you can see, right? So it will become a square minus b square. So I'll have 1 plus cos theta whole square minus of sine square theta. Clear? Rida, unmute your mic. Why you people are all on mute now? Hamna, Rida, unmute your mic, both of you.
Can you hear me, ma'am?
Yes. So try at least respond to me when I take your name, right? At least I should know you are here in the class. Okay, now look here. Now open the bracket of the numerator. So it is again a plus b whole square. That means a square plus b square plus 2ab. Clear? So I'll get 1 plus cos theta whole square plus sine square theta plus 2ab. That means 2 into 1 plus cos theta into sine theta. And now open this bracket in the denominator. It is again a plus b whole square. So I'll get 1 square plus cos square theta and plus 2ab, that is 2 cos theta, and then I have minus of sine square theta, right?
Yes, ma'am.
Okay, now again open this bracket. I'm opening all the brackets now. So this is again a plus b whole square. So 1 plus cos square theta plus 2 cos theta, and then other terms sine square theta plus 2 into 1 plus cos theta into sine theta. Now in the denominator, 1 plus cos square theta plus 2 cos theta. I can also replace this sine square theta as 1 minus cos square theta, right?
Yes, ma'am.
Because you can see 1 is cos square and minus of sine square. So I cannot do much here, right? So I'll change this sine square theta. Okay, now see here. Now look at these terms. I have cos square theta and plus sine square theta. So this will become 1, right? And 1 I have here. So 1 plus 1, 2. So I'll get 2 plus rest of the terms 2 cos theta plus 2 into 1 plus cos theta into sine theta. Now in the denominator, what will I have? 1 plus cos square theta plus 2 cos theta. Now you open the bracket. So minus 1 plus cos square theta, right? Now this 1 and 1 will cancel out. So now in the numerator, I can take 2 common from the first 2 terms. I have 1 plus cos theta and then plus 2 into 1 plus cos theta into sine theta. Clear? And in the denominator, I have now 2 cos square theta plus 2 cos theta, right?
Yes, ma'am.
Now in the numerator, I can take 2 into 1 plus cos theta common from both the terms. So I have 1 plus sine theta. Clear?
Yes, ma'am.
And then from the numerator also, I can take 2 cos theta common. So I have cos theta plus 1. Clear? Now this bracket will cancel out. 1 plus cos theta, 1 plus cos theta. And obviously 2 will also cancel out. So I'm only left with 1 plus sine theta and divided by cos theta. This is your RHS.
Ma'am, what if we equate the LHS and RHS?
Equate means what? No, no,
Ma'am,
no. You
like,
have to prove that this is equal to this thing. See, it's not given that LHS is equal to RHS. I mean, you are supposed to show that it is equal. Obviously, it is equal, but they are asking you to show that it is equal, right?
yes.
Yeah. So you cannot equate it. The question is that you have to prove it that this is equal to this thing.
Okay.
Hmm. Yeah. Any particular question? Anybody want to ask? Rida,
Yes, ma'am.
any question you are facing problem with? Tell me quickly.
I didn't write the fifth one, but I asked my mother and she showed me.
Sorry, your voice is not clear. Please say again.
I didn't write the fifth one, but after the exam, my mother showed me.
After the exams?
My mother showed it.
Sorry, Rida, I cannot understand clearly. Actually, your voice is a bit shaky. So please say again, what were you saying?
My mother solved it for me.
Okay. Okay, she solved it for you, right?
Yes.
Okay, okay. Sorry, I couldn't hear properly. All right, I think the rest of the questions were easy. So this one I found a bit lengthy, so I discussed it. Anyway, I'll send you marks. You will get the report card from the office. So let's come to the next chapter. I thought I should continue with trigonometry. So let's do some applications of trigonometry now. Okay. So I'm starting chapter number 9, some applications of trigonometry. All right. Now, before starting this chapter, you should know few terms. First of all, in this chapter, you are going to see, you will see the real life application of trigonometry where we use it in everyday life situations. And now try to understand a few things first of all. Like in every problem, consider a ground. Let's say this is my ground, okay? This is the ground on which you are standing, ground level or ground you can say. Now, for example, there's a girl who is she's standing here, right? Okay. Now she is looking at a building or a tower. Let's say I have a pole. Let's say this is a pole. Clear? Okay, this is the pole. Let's say. Now, always see these are the eyes. Okay. So obviously she is going to see from her eyes. Okay. So you have to take the level of the eye in every question. So this level, which is actually parallel to the ground, this imaginary line, this is called the horizontal level. Understood? All right. So this level of eye will be taken as the horizontal level. Now, if she is looking at the top of the pole, let's say, so obviously from her eyes, she will look like this. This is the line of sight. Clear? She is looking
Yes.
like this. So this is the line of sight. Now you can see this line of sight is making an angle with the horizontal level. Clear? You have two lines here. I mean, imagine it. Obviously, there are no lines in the space. These are all hypothetical lines. We imagine lines. That's it. So there is an angle here. Now this angle will be called as angle of elevation. So when she is looking at the top, this will be called angle of elevation. Now if she is looking at the bottom, like the bottom of the pole, obviously she is going to see like this. So this time the angle will be below the horizontal level. So this is called the angle of depression. So these are the three terms you need to be familiar with. What is angle of elevation? What is angle of depression? And what is the horizontal line? All right, Hamna?
Yes, ma'am.
Okay. So I hope it's clear. It's quite simple, right? So angle will always be made with the horizontal level, not with the ground, because you are going to see with your eyes. Okay. Let us start with some problems. Exercise 9.1. First question. So see in your book, all of you. A circus artist is climbing 20-meter long rope, which is tightly stretched and tied from the top of a vertical pole to the ground. So it's always better to draw a ground, first of all, like mark a line, which is your ground. This is my ground line. Okay. Now, there's a pole somewhere. Let's say there's a pole, vertical pole. And a circus artist is climbing a 20-meter long rope, which is tightly stretched and tied from the top of a vertical pole. So there is a rope like this. It is attached from the top of this pole and somewhere on the ground. And the circus artist is actually climbing this rope. Understood? Find the height of the pole. So if I call it AB, so you have to find AB in this case. If the angle made by the rope with the ground level is 30 degrees, so this angle is 30 degrees, right? And the length of the rope is given, that is 20 meters. So let's call this point C. So if I take it as a triangle, in triangle ABC, so obviously vertical pole means this angle is 90 degrees, right? Now I'm interested in finding AB. So that is perpendicular. So I have to take a trigonometric ratio which includes perpendicular and hypotenuse, because I know the value of hypotenuse here. So which ratio I can take? I can take sine, right?
Yes, ma'am.
And theta is already given. So sine 30 is equal to perpendicular. That means AB by hypotenuse, that is AC. So sine 30 is half. AB you want to find. AC is given 20. So your AB will become 10 meters. So you can conclude with a line that hence height of the tower is 10 meters. Okay, have you written?
Yes, ma'am.
Yes, ma'am.
Second question now. A tree breaks due to a storm. Okay, and the broken part bends. Let's say draw ground. This is my ground. I'm taking ground level. So there's a tree. It's a tall tree, and due to storm it breaks. Let's say it breaks at this point and bends so that the top of the tree touches the ground, making an angle 30 degrees with it. So if I give it some name, ABC. So this AB length will break and now it will fall like this, right? If I call it D, so basically your AB is actually equal to BD, isn't it? It's the part of the tree which is now fallen on the ground, right?
Yes,
Yes,
ma'am.
ma'am.
Okay, this angle is 30 degrees. So basically I have AB is equal to BD in this case. The distance between the foot of the tree to the point where the top touches at 8 meters. So this distance is 8 meters where the top touches the ground. Right. Find the height of the tree. Height of the tree means AC, complete AC you have to find, right? Is equal to AC. I mean, this you have to find, right? So AC means, try to understand first what we are supposed to do in this situation. I want to find AC. Now AC is actually AB plus BC, correct? So BC is simple. In this triangle, I know base, I know angle, I can find BC. And for AB, I can find BD, isn't it? If I find BD, now BD will be same as AB. BD is actually the hypotenuse of this triangle, right?
Yes, ma'am.
Okay. So first of all, let us try to find BC. So I take the triangle BCD. So this I want to find. Which ratio I should use? I know the base. I want to find perpendicular.
Cos.
Oh no, sine is perpendicular by hypotenuse. Cos is base by hypotenuse. I'm not going to the hypotenuse right now.
Tan.
Yes, tan. Tan of 30, that is perpendicular. That means BC upon base, that is CD. Fine, Arsha?
Yes, ma'am.
Okay, put the value. So 1 upon under root 3. BC I want to find. CD is 8 meter. So that gives you BC is equal to 8 divided by under root 3 meter. And you can rationalize it because you have under root 3 in the denominator. So BC is 8 into under root 3 divided by 3, right? Or I think because we are supposed to add at the last, so at the last we will rationalize. Don't do it here. So keep it like this. BC is 8 under root 3 meter. Okay. Now in the same triangle, I want to find hypotenuse, AD, right? I have base also, I have perpendicular also. So any ratio I can use now, sine or cos, whichever you wish. If I take cos 30 is base by hypotenuse, right? CD by BD, right?
Yes, ma'am.
Okay. Now cos 30 is actually sine 60, that is root 3 by 2. CD is again 8 meter. BD I want to find, right? So BD becomes 2 into 8 and divided by under root 3 meter, right? Same thing you will get sine also. Like if you don't want to use cos, if you want to use sine, let me just show you. So sine 60 is perpendicular upon hypotenuse. That means BC by BD, clear? So if you use BC, which you have already found, that is 8 by under root 3 into BD. And sine 30 is half. So from here, your BD will become like 2 into 8 divided by under root 3 meters. Clear? So same answer you are getting. All right.
Yes,
So
ma'am.
you can either find cos or you can either find sine 30 as per your wish. Now the height of the tree. Is equal to AB plus BC. Now AB is actually equal to BD and plus BC. So BD you have 16 divided by under root 3 and BC you have 8 divided by under root 3. So that becomes 16 plus 8 becomes 24 divided by under root 3 meter. Now you can rationalize it, okay? So it becomes like 24 divided by under root 3. So into under root 3 into under root 3. That becomes 24 under root 3 divided by 3. So that becomes 8 under root 3 meter. This is actually, AC, which which is AB plus BC. So AC comes out to be 8 meter. Sometimes in question, the value of under root 3 is given, that if under root 3 is this much. So if the value is given in the question, you can put the value of under root 3 and then multiply it. So under root 3 is actually 1.732, right? That's the value of under root 3. So if it is mentioned in the question, then you multiply it and then find the answer. Okay, done, all of you?
Yes, ma'am.
Yes, ma'am.
All right, now third question. A contractor plans to install 2 slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter. So like for smaller children, this is the ground, right? So for smaller children, she want to have a slide whose top is actually, slide is like this. The top of the slide is 1.5 meter from the ground and is inclined at an angle of 30 degrees. So this angle is 30 degree. Understood? Whereas for elder children, she wants to have a steep slide at a height of 3 meters. So if I just continue this ground level, so this time the height is going to be 3 meters. Obviously, when the height is increasing, the angle of elevation will also increase, right? This is 60 degree angle this time from the ground. What should be the length of the slide in each case? So you have to find the hypotenuse in each case. Clear?
Yes, ma'am.
So give it some name. Let me call it ABC and this triangle as PQR. So come to ABC, like in triangle ABC. I want to find hypotenuse and I know perpendicular. Which ratio I should use?
Sine.
Sine. Good. Sine of 30 is perpendicular by hypotenuse. That means AB divided by AC. So half is equal to, AB is 1.5 meter, AC you want to find. So AC will become 1.5 and divided by 2 meters, right? So it will be uh, in 2 into, right? Cross multiplication, 2 into 1.5. So that becomes 3 meters, right?
Yes, ma'am.
Same thing you have to do here in triangle PQR. Again, same thing, use sine 60 now. Sine 60 degree is equal to perpendicular. That means PQ divided by PR. So this is under root 3 by 2 is equal to PQ is 3 meter, PR you want to find. So PR becomes cross multiply. So 2 into 3 meter divided by under root 3. Now you rationalize it. So 2 into 3 into under root 3 and then divided by 3, right? So this 3 will get cancelled out. So PR will become 2 under root 3 meters. So So you can always conclude with a line, right? So hence, length of the slide for smaller children should be 3 meter or is 3 meter, right? And length of the child for elder children is 2 under root 3 meter. Okay, I hope you have written now.
Yes, ma'am.
Okay, now come to question number 4. Please read it. The angle of elevation of the top of the tower from a point on the ground. So this is the ground, right? And this is the tower. From the point on the ground, which is 30 meter from the foot of the tower. So from 30 meter away, you have to take a point, right? Now from this point, the angle of elevation is how much? 30 degree. Find the height of the tower. So if I call it ABC, you have to find AB. Clear? So I want to find perpendicular and I know base. Which ratio I should use here?
Tan.
Tan, very good. Tan 30 is equal to perpendicular, that is AB by base, BC. So tan 30 is 1 upon under root 3 is equal to AB I want to find. BC is 30 meter. So that gives me AB is equal to 30 meter divided by under root 3. So you can rationalize it. AB is 30 root 3 divided by 3 meter. So that becomes 10 under root 3 meters. Now, please note one thing here. In the previous chapter, we have discussed that trigonometry is applied on a right angled triangle, right? And in this chapter, they are not mentioning that angle is 90 degree, but they are using terms like vertical, right? And like vertical tower. So vertical tower means that the angle is 90 degree, all right? So you don't have to like mention it that this is 90 degree and like that. So it is clear from these terms. Question number 5th now. A kite is flying at a height of 60 meter above the ground. So you take a ground level. That's my ground. Okay. Now there's a kite somewhere. Let's say this is my kite flying. The kite is actually 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination is given 60 degrees. So there is a string. Obviously, the kite flies with a string. So that string is somewhere tied on the ground here. And this inclination is 60 degrees, right?
Yes,
See, a
ma'am.
kite never flies like this. Let's say you are standing and you are flying a kite. So it will never fly straight. Understood? It will go either here or here or here, like that it will fly. So this height is actually the vertical height from the ground which is given. But this is the thread which is attached to the kite, which is at an angle of 60 degree from the ground. Find the length of the string. So that means this length you have to find. Let me call it PQR. So PQ you want to find. Clear? Now what do I have? I have perpendicular. I want hypotenuse. Which ratio I should use?
Sine.
Sine. Good. So your sine of 60 is perpendicular. That means QR by PQ hypotenuse. Sine 60 is 0 half 1 upon root 2 root 3 by 2. This is 60 meter and PQ I want to find. So my PQ becomes 2 into 60 and divided by under root 3 meters. So you rationalize it. So PQ becomes 2 into 60 divided by under root 3. So into under root 3 into under root 3. So that becomes 2 into 60 into under root 3 and divided by 3. That becomes 2 into 20 into under root 3. So that becomes 40 under root 3 meters. So that's the length of the string. So hence,
Done, ma'am.
okay, 6 now. A 1.5 meter tall boy is standing at some distance from a 30-meter tall building. First, draw the ground. That's my ground. Okay. Now, a 1.5 meter tall boy is standing. So let's say here the boy is standing. So the height of the boy is 1.5 meter, right? I mean, this is the boy there. Okay. Is standing at some distance from a 30-meter tall building. So here's the boy standing, and then at some distance you have a 30-meter tall building. This is the building which is 30 meter. The angle of elevation from his eyes to the top of the building increases from 30 to 60 degree as he walks towards the building. First of all, angle of elevation is made with the horizontal level. Now, what is the horizontal level? Because this is the height of the boy. So with the level of the eye, you will draw the horizontal level. Understood? Clear? And the angle of elevation will now be formed with this horizontal level. So it was 30 degree earlier. Now the boy is moving closer to the building. Let's say he comes at this point. So the angle of elevation now increases and it becomes 60 degree. Clear? Find the distance he walked towards the building. So you are interested in this distance. I mean, this one. All right.
Yes, ma'am.
Okay. So give it some names. Let me call it A, B, C, D, E, F. Now, to use trigonometry, I need right angled triangle. So if I'm making use of 30 degree angle, so I need the triangle ADB. Clear?
Yes, ma'am.
Yes. And then 60 degree, I'll use ACP. Okay. Now I want to find the distance DC. That means if I find the complete distance AB and then I subtract the distance CB, so I'll get my distance DC. Clear?
Yes,
Now,
ma'am.
this distance AB can be found if I use the triangle ADB. And this distance CB can be found if I use the triangle ACB. Clear, Rida?
Yes, ma'am.
Yes. So let us start with
Ma'am,
this.
it's DB minus CB, right?
Oh, I'm sorry. I have written AB. DB, yeah. Sorry. DB minus CB. Okay. Now let us come to triangle ADB, 30 degree. I want to find base, right? So which
Yes.
ratio I can use here? And I know perpendicular. So which?
Tan.
Okay, tan. Okay. Tan is perpendicular by base. So how much is my perpendicular? Yes, Rida, you
30
tell me.
minus.
Rida, how much is my perpendicular in this case? Okay, I'm taking triangle ADB. So in triangle ADB, tan 30 is perpendicular by base. How much is my perpendicular, Rida? Hamna, how much is my perpendicular? Please unmute yourself, both of you.
AB
Yeah, what is the value of AB?
30 meter.
30 meter. Hamna, what about you? Now, Rida, look here carefully. This 30 meter is the height of the tower from the ground, right? The tower is not standing in the air. It is touching the ground. So 30 is complete length AF. Understood?
Yes, ma'am.
And you want to find the length AB. So first of all, you will find the length AB. So AB means your complete length AF minus BF. Understood? Now AF is actually 30 meter and BF is, now BF is same as DE. This is also 1.5, right? So minus 1.5 meter. So that comes out to be 28.5 meter. That's the value of AB. So you will write 28.5 and then divided by dB I want to find. Now tan 30 is 1 by under root 3 is equal to 28.5 divided by dB. So that gives me dB is equal to 28.5 into under root 3 meters. That's my length dB, the complete length. Okay, now you come to this triangle. In triangle ACB. Again, I want to find base and I know the perpendicular. So again, I can use tan 60 is perpendicular. That means AB by CB, right?
Yes, ma'am.
Under root 3 is equal to AB. I have found 28.5 meter and CB I want to find. So here your CB comes out to be 28.5 meter and divided by under root 3, right? Okay. Now I can find my length DC. So DC is now equal to DB minus of CB. So DB is 28.5 under root 3 meters minus CB is 28.5 divided by under root 3 meters, right? So you can take 28.5 into under root 3 common. So you have 1 minus how much? 1 upon if you are taking under root 3 common, so you need under root 3 in the numerator, right? So before this step, you can do one thing. You can do it directly also, but you can add one step. So 28.5 under root 3 meter minus, you can rationalize this one under root 3 and divided by 3 meters. Yes. So the second term I have rationalized. I mean, I have removed the under root from the denominator. I have multiplied numerator, denominator by under root 3. Sorry, now I can take 28.5 into under root 3 common. So I have 1 minus 1 upon 3, right? So this is 28.5 under root 3 into, this is 3 minus 1, that is 2 by 3, right? So am I doing it correct?
Yes, ma'am.
Okay. So you can just simplify it now. Now you divide this thing by 3. So this is 3 into 9 is 27 and then 15. So 9.5 multiply by root 3 and then multiply by 2. So you multiply this 9.5 by 2, it will become 2918 and then 0.5. So it will become 19 under root 3 meters. So this was a good question because many students make mistake here. Fine, Rida? You have to take it carefully. I mean, the 30 meter is actually from the ground, not from the horizontal level. All right, Hamna.
Yes, ma'am.
Okay, have you written? So I think one more question we can take quickly. Written all of you?
Yes,
Yes,
ma'am.
ma'am.
Okay. Now question number 7. From a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building. Okay, first of all, you have a building, okay? Okay, let's draw my ground. First of all, take your ground level. That's my ground. So there's a building which is how much? 20-meter tall. So the transmission tower fixed at the top of a 20-meter height high building. So the tower is actually attached on the top of it. So let's say this is the height of the tower. Understood? I can give it some name. Let's say X. Okay. X is like from here to here. This is your X. All right. Now read again. From a point on the ground, the angle of elevation of the bottom and the top of a transmission tower. So take a point on the ground. Now, once you are looking at the bottom of the transmission tower, that means you're looking at this point. If I call it A and B, right? So you're looking at B. So from the ground you are looking. That means this is the angle of elevation this time. Because see, the height of the observer is not given in this problem. You are looking means, I mean, there's a camera might be on the ground which is looking, right? So you have to ignore that height. From the ground level, you have to take your horizontal level also. Understood? Okay. So the angle of elevation of the bottom is 45 degree. And then you are looking at the top also. From the same point, you are looking at the top. So now this complete angle is 60 degree. Got the picture? Respectively, find the height of the tower. That means X you have to find. Understood? please draw the figure.
Yes, ma'am.
Okay. The height of the tower is actually x. So height of the tower is actually x you have to find, which you can find like AC minus of BC. This way you can find, right? So AC minus BC will give you AB. All right, so I take this triangle. In triangle ACD, the bigger ACD, my angle is 60 degree. I think I should start with the BCD triangle because I know the perpendicular, I know the angle, so I can find the base. Clear? Then I'll come to ACD. Is that okay?
Yes, ma'am.
Okay. So first you take in triangle BCD. If I take tan 45, tan 45 is equal to perpendicular upon base. That means BC and divided by CD, right? So it is 0, 1 upon root 3, 1. So this is 1 is equal to BC is given, that is 20 meter, and CD I want to find. So your CD becomes 20 meter. Clear? Now you come to this triangle ACD. Again, I use tan. So tan of 60 this time, the angle is 60. Perpendicular, that means x plus 20, or you write AC upon CD. So under root 3 is AC is now x plus 20. And divided by CD you have found, that is 20, right? You have to find the value of x from here. So 20 root 3 is equal to x plus 20, right? So
Ma'am, we can find AC by applying tan 60, right?
AC, but
Yes,
AC
ma'am.
is 20 plus x, right? Oh, you want to find complete AC.
Yes, ma'am.
Yeah, I think that way also you can do, and then you can subtract it, right?
Yes, ma'am.
Yeah, that also you can do. So let's see what comes out from here. So if I take like root 3 common, so I have 20 minus 1 is equal to x. So I get 19 under root 3x as my, sorry, is equal to x. So that's the height of the tower I'm getting. And what you are saying, Harsha, is this thing that you directly find AC, that 10 of 60 is AC by CD, right? So under root 3 is AC by CD, you have found 20 meter. So AC is 20 under root 3 meter, right? And then height of the tower means AC minus of BC. Now AC is 20 under root 3 and BC is 20. So the same thing, no, is it same? Somewhere I'm doing some mistake, Harsha. Wait, let me do it again. Somewhere I'm making some mistake. So is everybody getting the point what she's asking? Tan of 60 is perpendicular. That means AC divided by base, that is CD. Is this okay? Now tan 60 is under root 3 and I want to find the complete length AC. CD I have found, that is 20 meter. So that gives me AC is equal to 20 under root 3 meter. Right? So
Yes, ma'am.
if I want to find X, so that means X is equal to AC minus of BC. Now AC is 20 under root 3 and minus mm, 20. What will be under root 3 minus 1 I'll get? I think I have done some mistake here. Right? I think this is not the answer of the problem. Actually, my this side is also coming out to be 20 meter in this problem, right? CD, which I have found here. This is 20 meter. Now here I have done some mistake. I'll just check it again. So do it the pink one. Okay, this is right. So your x is this. You can take 20 common. So you have under root 3 minus 1 meters. So this is the answer I'm getting. Now come back to this. Here the mistake I have done. AC is x plus 20 and then divided by 20. 20 root 3 is x plus 20. Oh, Harsha, this was not minus under root 3. This was 20 minus 20, minus 20, right? Right? So
Yes,
ultimately
ma'am.
the same thing I'm getting. Under root 3 minus 1 is equal to x. So both way you'll get the same thing. So hence the height of the tower is 20 under root 3 minus 1 meters. So you can directly find AC and then subtract, or you can do it like this, x plus 20 direct here and then find the value of x. It's your choice. Hamna, have you understood? Rida? Okay, they have left. All right, Shirasha, today your assignment for trigonometry will be uploaded. So please just go through